All right, today we're diving into a skill that is absolutely essential for any AI developer, fine-tuning large language models. We're going to skip past the high-level theory and give you a real practical guide for 2025, when you should fine-tune, what methods you should use, and, maybe most importantly, how to avoid the common traps that can completely derail your project. Let's get into it.
You know, it's kind of wild how accessible fine-tuning has become. I mean, think about it. We can now take these massive 70 billion parameter models and actually tweak them on a regular gaming GPU. That's incredible. But all this power creates a new kind of problem. It's so easy to just jump in and start training without a real strategy, and that can lead to a whole lot of wasted time and money. So the real challenge now isn't just how to do it, but if and when you should even bother.
And that right there, that's the million-dollar question every developer has to ask themselves when they start a new LLM project. This is, without a doubt, the first and most critical decision you're going to make. And honestly, the right answer might not be what you think. This right here, this cuts through all the noise and the hype. The consensus from experts, we're talking folks at Google Cloud, Meta AI, is crystal clear. Before you even dream about training a model, you need to try the simpler, cheaper options first. If you only remember one thing from this whole explainer, please, let it be this.
Okay, so let's actually build a decision framework you can use. Before we get into all the cool technical details of how to tune, we need to get a rock-solid handle on the why. This is all about being a smart engineer, picking the right tool for the job, not just reaching for the biggest, most complicated hammer you can find.
So think of this as your roadmap. Your first stop, and I mean always your first stop, is prompt engineering. Can you get the result you want just by crafting a better prompt? If the model needs up-to-the-minute info or it has to cite its sources, then your next step is RAG. It's only after you've tried and maxed out both those options, only when you need to teach the model a totally unique style or a brand new skill, that you should even start to think about fine-tuning. And, data is the other huge factor here. This table gives you a super simple but really powerful reality check. Just look at that first row. If you've got less than 100 examples, just stick to prompting, seriously. There's just not enough information there for the model to learn anything meaningful. Now, as your dataset gets bigger, you can see your options open up, but this gives you a fantastic, practical benchmark to use for your own stuff.
Okay, so you've done your homework, you went through the hierarchy, you checked your data, and you've decided, yep, fine-tuning is the move. Well, the great news is you don't need a massive server farm anymore. The latest methods are all about being incredibly efficient, which makes this whole process accessible to pretty much everyone.
The magic that makes all of this possible is called PEFT, or Parameter Efficient Fine-Tuning. And the core idea is honestly revolutionary. Instead of trying to change all of the model's billions of parameters, you just freeze almost all of them. And then you only train a tiny, little, targeted fraction of them. And when I say tiny, how tiny are we talking? Well, get this. PFD methods often update as little as 0.1% of the model's total parameters. That is insane. And that's exactly why your memory requirements can drop by up to 3 times, and why your model checkpoints shrink from being hundreds of gigabytes to just a few megabytes. It is an absolute game changer. Now, let's break down the two heavyweights in the PEFT world today, LoRa and QLoRa. Deciding between them is actually pretty straightforward. If you've got a decent GPU and you absolutely cannot have any extra lag when the model is generating a response, LoRa is your go-to. But if you're on a tighter budget, maybe using a consumer GPU, or you're wrestling with a truly gigantic model, then QLoRa is your savior. Its aggressive quantization shrinks the model down so you can actually work with it.
So, teaching a model new facts is one thing, but teaching it a new behavior, like how to be a helpful assistant that actually follows instructions, that's a whole different ballgame. This process is called alignment, and it's what turns a raw, powerful base model into something useful like ChatGPT.
For years, the standard method for alignment was RLHF, and let me tell you, it was notoriously complicated and finicky. But the modern approach is something called DPO, or Direct Preference Optimization. The main thing you need to know is this. DPO gets you similar or sometimes even better results with about half the computing power, and it's way more stable to train. For pretty much all of us, DPO is the clear winner here. We've got our methods, we've got our tools, but let's be real for a second. The most sophisticated technique in the world will absolutely fail if you feed it bad data. Your success is built on the foundation of your dataset. That and your ability to spot and avoid the two biggest monsters in this process, overfitting and catastrophic forgetting. I honestly cannot overstate this.
Your number one job, the most important thing you can possibly do, is curate your data. 1,000 clean, high-quality, relevant examples will crush 100,000 mediocre ones every single time. As the errors in your data go up, the errors in your model can go up exponentially. You've heard garbage in, garbage out, right? Well, in this world, it's more like garbage in, catastrophe out.
So how do you know if things are starting to go off the rails? Well, the most common way these projects fail is through overfitting. That's where the model doesn't actually learn the task, it just memorizes your training examples. So let's look at the warning signs.
Here's a super simple checklist for you. The classic textbook sign of overfitting is right there in those first 2 points. Your training loss is going down, which looks good, but your validation loss starts to creep back up. That is a massive red flag. It means the model's acing the practice test, but it's not actually learning the subject. If you see that happening, you need to stop training immediately and either add more diverse data or use some other techniques to prevent the memorization.
The other major pitfall is a little more insidious. It's called catastrophic forgetting. This is when you successfully teach your model an amazing new skill, but in the process, it forgets how to do all the other general things it used to know. The best defense against this is to mix in a healthy amount of diverse, general instruction data right alongside your specialized training examples.
All right, we've covered the theory, the framework, and the big things to watch out for. Now for the fun part. Let's get practical. How can you get started, like right now, with a proven, effective stack?
Think of this slide as your perfect getting started recipe. This is a battle-tested setup for your first fine-tuning run. Start with a powerful but manageable model like Llama 318B. Use QLRA, of course, for maximum efficiency. Run it on a platform like Unsloth, which can literally double your training speed and slash your memory use. We've even thrown in some solid starting hyperparameters, from the learning rate to the batch size. This is your blueprint for a successful first run.
So there you have it. You've got the framework to know when to tune, you have the efficient methods like QLoRa to actually do it, and you have a practical stack to get started today. The road from a generalist AI to a specialized expert has never been clearer. So the only real question left is, what specialized skill are you going to teach your AI first?